So from now on, we'll be starting to study the major branches of physics, right? So these are some of the very major branches of physics. Starting from this, we have mechanics that deals with the study of motion of objects. It is the oldest branch, one of the oldest branches. And then we have thermodynamics, where we study about the heat and equations of heat. In optics, we study about light, the study of light and its nature, its behavior. Then we have the study of electricity, magnetism, and their mutual relationship. So we study it in electromagnetism. The next branch is quantum mechanics, where we see uh, at to things at the atomic level, at the very very smallest level. So the study of atomic studies. Next, we have nuclear physics, where we basically focus on the nuclei of an atom, the behavior of nucleus, the particles inside, and the reactions taking place at the nuclear level. Next, we have astrophysics, where we study some phenomena and the nature of celestial objects, the planetary motion. So it comes in this field. And acoustics, we study about the nature of sound and some laws governing sound. Then we have this field of relativity in modern physics. And in relativity, basically, we study about space-time curve, the nature of space, the nature of time, and lastly, we have biophysics. In this branch, we study about how physics is related with the biology. All right. So now we move forward. So here we have, first of all, we'll study about mechanics. What mechanics is. So mechanics is the branch of physics that deals and studies about the motion of objects. Also, the forces that cause such motion. So it is the oldest and one of the most fundamental branch of physics, right? And it is further subdivided into other branches. First of all, we have classical mechanics, and in classical mechanics, basically, we deal with the motion of macroscopic objects using laws of Newton, Newton first law, second law, third law. And classical mechanics includes kinematics, dynamics, static and circular motion. So this is all about classical mechanics, and kinematics basically describes the motion without basically regarding to the cause behind that motion. Displacement, velocity, acceleration, all of this comes under this kinematics. And okay, so further we have the next branch of mechanics, which is quantum mechanics, and we study the motion at subatomic scales, where classical laws basically break down. So wave particle duality is a very huge and important topic we'll be studying later. So this is all that we basically study in quantum mechanics. When the particles are very very small, electrons and protons and at photons level, the classical mechanics fails. So then quantum mechanics takes over. Then we have fluid mechanics. So in this fluid mechanics, we basically study the behavior of fluids, the behavior of liquids and gases. Bernoulli's principle is one of the most famous principle and a famous topic that we'll be studying later. Also, we study about Pascal's law, Archimedes' principle. All of this basically comes in this fluid mechanics. Okay, and then we have relativistic mechanics, and which basically deals with the motion of objects at speeds closer to the speed of light at very fast speeds, governed by the Einstein's special relativity theory, right? Okay, so moving forward to the next branch of physics, and we have thermodynamics. So as the word says it all, thermo means heat. So it is the branch of physics basically that deals with heat, temperature, work and energy, and how they are basically interrelated to each other. So it governs basically everything from steam engines to living cells. And basically this therm is a Latin word. No, sorry, it's a Greek word. Yeah, it's a Greek word, and it means heat, and dynamics means power. So as we studied, it governs engines, refrigerators, stars, and living cells, basically everything. And then there are basically four laws of thermodynamics: zeroth law, first law, second law, and third law. So I think there's no need to explain these laws right at this moment. We'll be studying these laws later on in this course. Some key figures are Carnot cycle, Kelvin, and Joule. What is Joule? Boltzmann constant. So we'll be studying these things later, right? Now moving to the next branch of physics, we have optics. So optics is the study of light, its nature, behavior, interaction with matter, and the instruments that are built to detect light or use it. Okay, and furthermore, we can subdivide this the branch into sub branches. The first one is geometrical optics. In this geometrical optics, basically, it treats as light as rays traveling in straight lines. And geometrical optics basically, this is valid when the size of an object is very, very large than the wavelength of light, right? So we will deal with the laws of reflection, the Snell law of refraction, mirrors, concave mirror, convex mirror, lenses, fiber optics bases. So all of these topics, they are basically covered under this sub branch that is geometrical optics. Next we have is the physical optics, and this sub branch basically treats light as a transverse electromagnetic wave. Okay, and necessary when light passes through openings or around objects comparable in size to its wavelength. So we'll be studying about the interference of light waves when they superimpose, and the constructive and destructive interferences. We'll be studying about the polarization of light. Young's double slit experiment is a very famous topic. We will be studying it later. And this is another branch of basically physical optics, is a sub branch in which we'll study these topics, right? Finally, we have quantum optics, where we'll be studying about the photoelectric effect. The 1904 discovery of Einstein, uh, it was that light comes in quantized packets. He named it photons, and this concept basically earned him a Nobel Prize as well. So we'll be studying these topics under this sub branch of physics, under this sub branch of quantum optics. Moving forward to the next branch of physics, the next major branch, which is electromagnetism. As the name reflects, it shows electricity, and this shows magnetism. So we'll be studying about four fundamental forces basically. But first of all, the definition: electromagnetism studies electric and magnetic fields, their relative interaction, and the electromagnetic force. So one of the four fundamental forces of nature. All right. So the core concepts basically in electromagnetism are Coulomb's law, which studies with the charges, basically electric fields and potentials, magnetic fields, Faraday law of induction. These are basically very, very important topics when We're studying electricity and magnetism as well, EM waves, AC circuits, and this field is basically the application of this field basically is in all these subjects, in motors, in generators, in transformers, power grids, radio, communication, TV, smartphones, basically everything it deals. These are all basically some real world applications of electromagnetism.